Now this is RD Sharma solution class 12. Chapter 19 we are taking. Exercise is 19.1 indefinite integrals. Before going to the exercise, let us understand what is actually integrals. There are two types of integrals, indefinite and definite. So we'll talk about indefinite integrals right now. Integration means adding. Differentiation means dividing the content into smaller parts. For example, if we need the average speed for a distance, it's easy to know. But if someone comes and asks, I want exactly the speed at this particular point, then we need differentiation. So differentiation is all about dividing the content into smaller parts, and integration is adding these smaller parts to make a bigger part. For example, addition, 2 plus 3, that is addition. And if you want to add, say, from 1 to 5, then we add a sigma sign, sigma from 1 to 5. And the bigger part or bigger version of plus sigma is integration. So integration of any function with respect to dx. If you remember, the differentiation, whenever we differentiate a function, we write d by dx. So the differentiation is with respect to x. Similarly, the integration also is with respect to certain variable, that variable which the function has. So when we collect, we are talking about integration. So integration and differentiation are counterparts to one another. From here you will know that the formula, when I will present it to you, you will see that they are actually the counterparts. The formulas are opposite of integration and differentiation. So if you remember the formula of differentiation, you will be able to easily recognize the formula of integration also. For example, if you have a function fx, so there is a snake-like sign. This snake-like sign is indicating the integration. So fx is the function, then the differentiation or integration is respect to dx. And the result come if you write it as capital Fx. Always remember we have to have a constant of integration. All these, this first sign or symbol, which is the snake-like symbol, is integration symbol. The function which is to be integrated is called integrand. And the dx, which is the differential of x. Okay, because as I said, integration and differentiation are counterparts. They go together hand in hand. The result is fx. We are not calling it as integral, but we are calling it as antiderivative. So antiderivative and integral are the same thing. Antiderivative written here because I want to relate the integration with the differentiation. And of course, we have the constant of integration. For example, if you differentiate x plus 5, differentiation of x is 1, but the differentiation of a constant value is always 0. Similarly, if you have another function, say x square plus 5, again this scenario remains the same. Differentiation of x square is 2x, but the differentiation of 5 is 0. So whenever we differentiate, the constant part is eliminated. So in order to get the reverse of it, that is the integration of this, we need to add a constant of integration. So this differentiation value constant which has been eliminated is plus c. So the standard results of differentiation, same way we have the integrals. So these are the standard result. So whenever we have these results which are known to us, we can directly use in solving the question. We have d by dx of x raised to n. So the differentiation was n x to the power n minus 1. But when we integrate it, what do we get? So as I am saying again and again, integration is opposite of differentiation. So integration of x to the power 1 is x to the power n is x to the power n plus 1 by n plus 1. Now what do you see here? Now this has come if you try to differentiate this one. That is the right part. The right hand side I am differentiating now. You will see that the left part will come. Differentiation d by dx of x raised n plus 1 by n plus 1 is n plus 1 can come in the front, that is in the denominator, and x to the power n minus 1, that is the differentiation, so n plus 1 come in front, x raised to n plus 1, n x to the power n minus 1, so n plus 1 minus 1 is n only, x to the power n, and n plus 1 gets cancelled, so you get x to the x raised n. So now you can imagine and anticipate that how this differentiation and integration are counterparts. Integration is all about this symbol which is the snake-like symbol, and integration differentiation, they cancels out as they are opposite. You can say they are inverse of each other. They are reciprocal of each other. In this way you can remember that thing. So I hope these are the standard results and these standard results are going to be used. I'm not going to discuss all of them because in the question we are going to use them immensely. Differentiation of sin x is cos x, but what is the integration of cos x? It will be sin x. Sin x differentiation is cos x, integration of cos x is sin x. But one thing is there, you have to add a constant of integration which is plus capital C. Let us take one more example. We have sine inverse x. When we used to differentiate sine inverse x, it was the standard result, 1 by under root 1 minus x square. This was the standard result. But when we integrate this 1 by under root 1 minus x square, this same thing which was differentiated, which has caused this 1 by under root 1 minus x square to come, will again resurface. That is sine inverse x plus c is the integration of 1 by under root 1 minus x. So these are all the standard result, and these are few of them. There are many of them which we will be discussing when we actually come across the question, and I'm going to present it to you. Don't need to remember, just see the question, do the questions, and that is all clear to you. We will use the standard result, and as I'm again saying, practice makes a man perfect. Evaluate the following integral. Now this integral, now you need to be very careful and attentive. Why? Because this will start. The first ball in the cricket is the decider of the whole match. So this is the first question, and all the exercises which are going to come, this is a very big chapter. So integration of x raised 4. There is a dx also involved. So we are integrating with respect to dx. Now integration of x raised power n, the standard result is x raised n plus 1 divided by n plus 1. This is the standard result. And when we this will be known to you, this will be actually feeded to you in the mind after we do certain questions like this. N is 4 here, use this formula. X raised 4 plus 1 divided by 4 plus 1. And there is always a constant c that needs to be added. X raised 5 divided by 5 plus c. Now this is the standard result of the integration. So whatever I have told you, this is the actual representation. If you are writing, then just go about it. I'm not writing the English we have and this and that thing. That will be later for the higher questions. Now these seems to be very easier question, but this will make a base. So x raised 5 by 4 dx. Again, x raised n. So n is 5 by 4, and we have a standard result. We just have seen in the previous question. It is x raised n, integration is x raised n plus 1 divided by n plus 1. And there is one more thing, which is the constant of integration. Here also we are going to do the same thing. X raised this 5 by 4 plus 1 and divided by 5 by 4 plus 1. So x raised n plus 1 divided by n plus 1, and again the constant c I'm going to add just now. So 5 by 4 plus 1, if you have any problem, the only thing is cross multiplication. 5 into 1, write it here. 4 into 1, write it here with a plus. And then 4 into 1, that is the denominator multiplication in the denominator. So you get 9 by 4. X raised 9 by 4 divided by 9 by 4 plus constant of integration. And 9 by 4, of course, when it will go up, the 4 will be up and 9 in the denominator. So 4 by 9, x raised 9 by 4. And then we have the constant. What is the important thing? Constant of integration has to be added. So even if somebody wakes you up in the middle of night and say integration, you have to understand it comes with plus c, that is the constant of integration. Because when you learn about the definite integral, then you will understand what is the importance of this plus c, and even in the other questions we are going to take just now. So this is the result. Now you can follow this. Evaluate the integral, which is 1 by x raised 5 dx. So the way we used to do this in the differentiation part, same thing we are going to do. So this x raised 5 we are going to take in the numerator. X, whenever the numerator x raised 5 goes, it will be negative 5. So x raised negative 5 dx. What is this standard result of integration of x raised to power n? It is x raised power n plus 1 by n plus 1. What is n here? N is negative 5. So now use the formula. Negative 5 plus 1 is negative 4. So x raised 4, negative 4 divided by n plus 1 again. So negative 4 in the denominator. So now you have known the basics of integration, how it is performed. Don't forget this plus c. This is how it is done, which I just explained you. Next one is integration of, there are certain different kind of flavors of the basic formula of integration. of x raised n. So we have x raised 3 by 2 in the denominator. We'll take this denominator to the numerator, that is x raised negative 3 by 2. And this is 1 by x. 1 by x will go up, x raised minus 1. That is x raised minus 1 is simply 1 by x. It is the standard result. So same thing we are applying here. X raised negative 3 by 2 goes up. And when we integrate, this integration will, once you integrate, integration sign will not be written again. This is the result. So x raised n plus 1 divided by n plus 1, n is negative 3 by 2. We are actually adding 1 with negative 3 by 2. So 2 minus 3 by 2 is just negative 1 by 2. Negative 1 by 2, and anything to the power 1 by 2 is nothing but root only. If you write x raised half, that is simply meaning you are talking about root x. So x raised negative half divided by minus 3 by 2 plus 1 is n plus 1. Again negative half in the denominator, so this negative half 2 will go up. This is not minus half, 2 will go up. So I'll just cancel this. So this negative 2 will go up. Final result is negative 2 divided by x raised negative half will come in the denominator. It is x raised half, which is root x. So negative 2 divided by root x is the final result, but there is one more thing which is remaining, which is the plus c, constant of integration. So this is the result. This is how we have done. Evaluate the following integral. Again, this is a different kind of question, that is different formula we are going to use. The standard result of a raised x dx is simply a raised x divided by log a. A is a constant, x is a variable. So the log is base e, remember. This a here is 3. We'll use the standard result, and this is 3 raised x divided by log base e is already there. So log base e, we generally write it as ln. This is ln. ln 3. 3 raised x divided by ln 3. Constant of integration, don't forget. So now these two formulas we have taken. This is the standard result, only one line solution. Now evaluate the following integral. So if it would have been under root x square, for example, under root is simply power 1 by 2. So since x square is there and it would have been, I'm just imagining, I'm just guessing. So if it is under root x square, this x square to the power half, under root is simply to the power half. So x square to the power half, and this power and the power can be multiplied. So 2 into 1 by 2 is 1 only. So under root x square is simply x if it would have been under root. But the scenario is different here. I'll just show you. 1 by cube root of under root x square. The things have changed here. I'm just saying that under root 3 is there. It can be under root 4, under root 5. So it can be nth root. Nth root. It can be any n. I told you about 2. The question is about 3, but it can be any n. So the third root of this x square, what do we get? This is x square, and this third root is simply raised to the power 1 by 3. The root or the nth n comes as the 1 by of n. So this 2 and 1 by 3 will be multiplied, so x raised 2 by 3. So actually this third root of x square is simply x raised 2 by 3. Now let us differentiate. So x raised negative 2 by 3 goes up, this is dx. Now we have the standard result. X raised n integration is simply x raised n plus 1 divided by n plus 1. And we have a constant of integration. So minus 2 by 3 plus 1 is 1 minus 2 by 3 is what? 3 minus 2 by 3, this is 1 by 3. So this is integration, and just remove this integration sign now because you are writing the result of the integration. It's x raised 1 by 3 divided by 1 by 3, and with the constant of integration, this 1 by 3 in the denominator will go up. 3 into x raised 1 by 3 plus c. This is the standard result of this solution. So we have understood about the under root also. We have understood the third root and nth root. So the things remain the same. The proceedings remains the same. I hope you'll be able to do it. Next one is integration of 3 and 3 to the power 2 log base is again 3, and we have x here. So if you are aware of the properties of logarithm, this question will be quite easy for you because log m raised n is simply n log m. This power comes in front. So log m raised n is n log m. So we have 2 log base 3x. This x goes to the power because it is twice log base 3x. So 2 goes to the power, it becomes x square. So we have log base 3x square. So now we have 3 raised log base 3x square. So we will use one more property of logarithm. What is that property? 3 raised log 3. Now you know when you have a constant and the base is also constant, this gets cancelled out. In log and exponential, you have learned about it. So if you have a raised log base a, this get cancelled. So you only get this x which is inside. But here we have x square inside. So this 3 raised log 3 gets cancelled. You get x square. Now all this comes down to x square. So x square dx it is, and when we integrate it will be x cubed by 3 because x raised n is x raised n plus 1 by n plus 1. It is x cubed by 3. This is the direct result along with the constant of integration. This you can do, I hope. Next one is log base x dx. Now the integration is very simple here because log base x is 1. Now I will just revisit those log properties so that you understand why this log base x is 1. So if you have log, say base is a, this is also a. This gets cancelled. For example, if you have log a b equals to c, this is the standard result. So log base a b equals to c, that simply means a raised c equals to b. So a to the power c is b, this is the standard result. Similarly, if you have log base x, what does it mean? If I equate it to say 1, because I know what is the standard result, this simply means x raised power 1 is equal to x, and this is actually true because x is equal to x. So that means log base x is 1. So you are actually integrating 1 here. Integration of 1 is what? Integration of 1 is what? See, 1 is nothing but x raised 0. X to the power 0, or in by virtue of this property, anything to the power 0 is 1 only. So x to the power 0 is 1. So in place of 1, you can write x raised 0. And now you can apply the standard result. X raised n plus 1 by n plus 1. N is 0 here. It is x raised 0 plus 1 by 0 plus 1. You get x by 1, which is x only. So integration of this is x along with the constant of integration. X plus c, this is your result. So this is how we have done. There are certain things away from this which I explained you just to revisit your earlier classes. Evaluate. This is the integration of under root 1 plus cos 2x by 2 dx. Now before we go ahead, there are certain standard results which we need to discuss. And these result is cos 2x or cos of twice theta is equal to, there is a relationship of cos with cos square and cos with cos 2 theta with sin square also. So cos 2 theta is equal to 2 cos square theta minus 1. That means 2 cos square theta is equal to 1 plus cos 2 theta. So in place of 1 plus cos 2 theta, we can replace 2 cos square theta. This 1 plus cos 2 theta, 2 cos square theta. Okay. Now put it here. So you have 2 cos square theta or cos square x divided by 2. And remember, this is under root, inside a root, integration sign with a dx. Dx is always there, okay? Now 2 gets cancelled, cos square x will be, see, if it is x square, that only means that you are having a power of half. 2 and half cancels. That is, under root x square is as good as x. So in place of x square under root, we can write x. Similarly, in place of under root cos square x, we can write cos x. Now integration of cos x has to be performed, and this is sin x. Sin x differentiation is cos x. Cos x integration is sin x. But one more thing is, you have to add a constant of integration. This has to be added. Okay, this is the whole thing so what we discussed is here, and this is how you have to do it. Now the same thing, we have just did a question with 1 plus cos 2 theta or 1 plus cos 2x. Here also it's 1 minus cos 2x. So I told you cos 2x relationship with cos square. Now we'll have a relationship with sin square. Because cos 2x is simply cos square x minus sin square x, and cos square x plus sin square x is 1. So you can use these two in order to get this 1 minus 2 sin square x. 1 minus cos 2x we want. 1 minus cos 2x is equal to twice of sin square x. When you have this 2 of sin square x, now this 2 sin square x, it is in front of you. 1 minus cos 2x can be replaced by 2 sin square x. 2 sin square x divided by 2. And this is in under root. You can cancel these 2. It has been integrated now. Sin square x is sin x only. When it comes out of the root, you can eliminate the root and you are going to integrate only the sin x in respect of dx. Now sin x differentiation what? It is The cos x differentiation is minus sin x. Therefore, the integration of sin x will be minus cos x and plus a constant. Integration and differentiation, they are complementary to each other. Now you can solve this like, and you can write English like sentences like we have, all these since, evaluate. We are integrating this one. Before we go ahead solving this question, there are certain standard results which are related to exponential and log. So if we have a log b, that simply means this is the power of b, that is log b raised a. So the power of b, which is a in this case, comes in front. Same thing is here. This is going to be used here. There is one more thing which we are going to employ, which is e raised log e. E to the power log e, this gets cancelled. That is just 1. So this we have e raised log base e. Now we need to integrate here. This 6 goes up. X to the power 6, x to the power 5, x to the power 4, x to the power 3. All 4 terms are exactly similar. So whatever I am doing with one term applies to all the terms. We have e log base e is there. Log base e is specifically given. So x raised 6, e raised log base e x to the power 5, and base e is already there. In denominator we have e raised log base is already e x raised 4 minus e log base is e x to the power 3. Now I already told you that e raised log e will be 1. So only x raised 6 remains. Here x raised 5 remains. Here only x to the power 5 will remain. X to the 4, and this is x raised 3. So x cube, and we are integrating it with respect to dx. Now we can take x raised 5 common, we'll get x minus 1 inside. Here we can take x cube common, we'll get x minus 1 inside. This x minus 1 gets cancelled. X raised 5 by x cube is x square. Because x cube will go up, it will be x raised minus 3. 5 minus 3 is 2. When you have x raised a, x raised b, that is if the base is same, the exponents get added. X to the power a plus b. So 5 minus a. Remember, minus or negative always overpowers the positive sign. So 5 plus minus 3 is simply 5 minus 3, which gives you x square. Okay, now whole of it is x square. So integration of x square is done here. And this x square dx is simply, because all is with respect to dx, integration of x raised n is simply x raised n plus 1 divided by n plus 1. What is n here? See, n is 2. Integration is already done. So now we can forget about the integration sign. It's x cubed by 3 plus c. This is your final result. So this is how it needs to be done, and all the English like sentences we have done this, all this can be written. Now we are integrating 1 by a raised x and b raised x dx. A to the power x and b to the power x. Now integration of a raised x is simply a raised x divided by log a. The base is e. A raised x integration is a raised x divided by log base ea plus constant of c. One more thing is going to come in solving this question, which I am going to actually present it to you right now, which is 1 by, if you have ax, if you take it in the numerator, it will be a raised minus x. A raised x goes up, it is a raised minus x. Similarly, b raised minus x dx. Now we can add, these bases are not same. Okay, bases are not same. That means if you have m to the power 2 and n to the power t, this simply means mn to the power 2. Now this, if the exponent are same, you can just combine these bases and multiply them and keep one exponent over it. This is ab to the power minus x. Now this is as good as this one only. But right now I will not tell you, because it is going to come in the another exercise. There is a whole exercise for that. Just simply say that minus x is some t. So it will be as good as integration of a raised t dt. So this is simply ab to the power minus x divided by log base is e, and what is a here? ab. But here a negative sign will come, because you can just assume that we are differentiating negative x and putting it here, or there is another way to understand this, because as I said, it's going to come later on. The whole exercise will be discussing upon it a lot. But when you have this one, I'll just give you a hint what exactly we have done. We take minus x equals to t. Then we differentiate both the sides. When you differentiate both the sides, this is d by dx of negative x is equal to dt by dx. That is, d by dx of negative x is negative 1. It is dt by dx. So dt equals to negative dx, or you can say dx is equal to negative dt. We will use it interchangeably. So it is essentially equal to, the second step is integration of ab raised t. When we integrate it with respect to dt, remember dt is negative dx, so negative sign has already come. This is ab to the power t divided by log base e, and this is ab. Now t needs to be replaced by negative x because we cannot have t we have chosen, so we have to actually replace it by x while we complete this question. Now dt is negative dx, which you see here. So we put negative dx, that is how the negative sign has come. That is why I am saying this negative sign will also come, and of course plus c constant will remain there. So this whole exercise is coming later on, but right now this is the solution. This is how negative has come, because you might be surprised how this negative has come. We've used the formula. So this is your final result. So whatever I told you, it's just an explanation, but the solution is just 2 or 3 steps. And if you add all which I said, that will be supplementary. Now evaluate cos 2x plus 2 sine square x divided by sine square x dx. So cos 2x is simply 1 minus 2 sine square x. So we'll use this one. Cos 2x is 1 minus 2 sine square x. Just replace cos 2x by 1 minus 2 sine square x. 1 minus 2 sine square x plus 2 sine square x divided by sine square x. This 2 sine square x is and negative 2 sine square x gets cancelled. They are similar with a plus and minus sign, so you can cancel them. 1 is there, sine square x is there in the denominator. 1 by sine x is what? Cosec x. 1 by sine square x will be what? Cosec square x. We have cosec square x differentiation going on in here. Cosec square x differentiation is, if you remember the differentiation of cot x. What was cot x? It was somewhat related to cosec square x only. So integration is just the inversion of differentiation. You can write it as negative cot x. Cot x is minus cosec square x. So this comes like minus cot x plus c. This is the entire solution. Whenever you want to solve it, you have to do it like this. Okay. Similar way, we have done the formulas, applied it to previous questions. The cos 2x is simply 2 cos square x minus 1. What do we get here? In place of cos 2x, when we replace it by 2 cos square x minus 1, will be 2 cos square x minus 2 cos square x minus 1 divided by cos square x. This 2 cos square x minus 2 cos square x plus 1 you will get. That is, this when you open this bracket, you will get this 2 cos square x get cancelled. 1 by cos square x is the final thing. You always have this dx with them. I just don't write it because it's by default. 1 by cos square x, 1 by cos x is what? It's sec x. So you can just write this 1 by cos square x as sec square x. It will be squared. You have a dx here. So integration of sec square x will be tan x, and this is tan x plus c, constant of integration. This is your final result. So this is how you are going to write it. Next one is integration of e raised log under root x divided by x. Now as I told you earlier that e raised log base e will become 1, and under root x is already there. Under root x is simply x to the power half. So e raised or e to the power log base e, or if you have e to the power of log with a base e, it gets cancelled. So this explanation tracks you back to the logarithmic and exponential classes. So under root x will remain. X is already in the denominator. Under root x is simply x to the power half. X is in the denominator. This goes up. X goes up, so it will be x raised minus 1. Half minus 1 is negative half. So x raised negative half divided by, there is nothing in the division because x has already gone up. So x raised n integration is x raised n plus 1 divided by n plus 1 plus constant of integration. N is negative half here. Integration of x to the power minus half plus 1 divided by minus half plus 1 dx. So integration is already done, so you can just remove this sign, this snake-like sign. X raised 1 minus half is half only. The denominator is 1 minus half, so it will be half, and that 2 will go up. So twice of x raised half is twice of under root x. X raised half is simply under root x. Initially also I told you this is 2 under root x plus c, which is the final result. So this is how you are going to complete this question. Okay, this is a very short exercise, first exercise, but we have over 30 exercises. Okay, so see you then. Thank you so much.